Can you hear me?
Yes.
So let's start now. We have a testing techniques.
Mhm.
So we have seen different test levels. Now testing process we have seen, Agile process we have seen, Agile methodologies. So different methodologies we have seen, waterfall methodology, Agile methodology. So we have seen
Mhm.
techniques. So how you need to perform the testing, how you can design the test cases. So basically, if you want to design the test cases, you need these testing techniques. So there are two types of testing techniques: static testing technique, a dynamic testing technique. Static testing technique means, so basically just, you will just examine the documents or application manually. So you are not going to perform any execution. So just you will verify whether it is there or not. And you just observe. So it is present or not. So this document is correct or not. That's what you will do in the static testing technique.
Mhm.
And how you will do static testing technique? With the reviews, inspections, and walkthroughs. These are the three process you will use static testing technique. Static testing technique also called verification process, basically, right? So these
Yeah, I
are
was
the
about to say this is a callback to verification versus validation.
exactly verification. Basically, it's a verification. Next one, a dynamic testing technique. So dynamic testing technique means basically you are executing the software.
Mhm.
So when you perform the action on the any web page, internally code will execute.
Mhm.
That is called dynamic testing technique. So dynamic testing technique means you just see, for example, you click on this. So
Mhm.
the code will execute.
Mhm.
So if you see this, the sorting, so you can reorder the elements. This the code will execute.
Mhm.
Whatever you do. That's the, so basically, see the page is changing, right?
Mhm.
Page is changing means it's a code executed internally and moved to different page. That is called dynamic testing technique. So dynamic testing technique is nothing but, so software is executed using a set of input. So you are giving input like click action is an input, or
Mhm.
something you can type somewhere. That's input. And it will give the output to us. Output means, for example, you clicked, you clicked on this element, it went to other page, right? That's output.
Mhm.
So every input and the output will be generated. So that is the dynamic testing technique. So internally, the software is executed. So by giving a input data or input actions, and you will output the output, you will be verified. Basically, you will compare. So with the expected and actual. So when I click on this link, so this should land this page. Whether it is
Mhm.
landing in this page or not, you will verify. Once the actions are done, you will do verification also. So that's called a dynamic testing technique. So
Mhm.
dynamic testing techniques are three types: black box testing, white box testing, gray box testing. So what are the three types? Black box
Black
testing,
box, white
white
box, and then
box,
gray
gray
box.
box testing. So these are the three types of dynamic testing techniques are there. So what is a black box testing? What is black boxes? Black box is mainly focus on external behavior of the application. See, this is the behavior, right? So I
Mhm.
clicked on this. So this is the behavior changed.
Mhm.
I clicked on this. So the behavior changes, right?
Mhm.
So this is the button element, anchor element. So these are all the different actions, right? So
Mhm.
that's if you click on this, it will go to date picker. See, this is the actions you visible for you, right? So when you are performing action, it's visible for you. That's the external behavior of the application. When you perform the action, the pages will change, something will appear for you. The externally, you can see the behavior change. So that is called a black box testing. So black box testing mainly focus on external behavior of the application, not based on any knowledge of internal code. Internal code means code you won't bother what code the developer has written. So externally, how it is behaving. So is it going to next page or not? Is it taking the input or not? Is it so navigating to different pages or not? It is producing the proper output or not? That's what you will see in the UI. That is called black box testing or called functional testing. Black box testing also called functional testing. So test cases are based on purely on the requirement based. That is a black box testing means. So a simple example of black box testing is a TV. So you take a television, okay? So as a user, we watch the TV, right? But we need the knowledge of how the TV is built, how it works. How it works will work. So, but how it is built, we are not bothered about it, right? But whether it is working or not, you will bother mostly. So how to operate with the remote control, switch on, switch off, change channels, increase the volume, and all this is the you're checking the functionality of the TV, right? So that's all functionally how it works. That you will focus more. That is called black box testing means. So the TV is under application under test. So in this example, okay, in this example I'm giving. So remote control is the user interface that you use to test it. So you need to know how to use the application first, right? Generally, how to use the particular anything, mobile or anything you take, you should know how to use that, right? Without knowing, you cannot use that, right? That is no. Initial testing is done by testers only. Initially, the application or product used by the testers only before any other person. First, you are the person, you will use how it works. So that's a black box testing. The advantages of black box testing is any person can learn. You don't need to be a technical guy. You don't need to, any coding doesn't require. So that's the main advantage. Anyone can learn, but everyone has a testing skills. So you know, right, whether it is correct or not, you easily know, right? So that is the same thing you will apply in the applications also. So you will verify actual application behavior and the requirements, what they have given. Both are any differences are there, you will verify. That's a main any person has to do. Other than that, nothing to worry about. Everything will be in the requirements. You read one by one requirement or derive in detailed test cases, then you test it. Test case can be designed as soon as the functional specifications are required or complete. That means when you will design the test cases, once you have a user stories or requirements, functional requirements are ready, then you will start designing the test cases. That is the advantages of so advantage of black box testing. So the disadvantage of black box testing is, so input needs to be taken from large sample space. For example, you are testing one form in the web page. You have to give different first names, last names, and postal code, zip codes, right? Zip codes, and phone numbers. You have to gather all of them. So, for example, you have to test a particular state, US state or US states or no UK phone numbers, US phone numbers, and so different India phone numbers you want. How you will do that? You have to gather all those phone numbers, right, as a test data. That's a bit difficult to gather the test data. You have to gather from large sample space. So that's one thing. It is difficult to identify all possible inputs in limited testing time. So you cannot finish all the possible inputs in a small, because they'll give less time for you. You have 2 weeks span. In the 2 weeks, you won't get everything all 2 weeks. Hardly will get 3 to 4 days or 3 days. You have to complete the testing, because the development team will take more time, right? So they have to develop it and then they will give it to you. If you want to, so test it and you won't have a sufficient time. So that's why, so writing test case is also slow and difficult. It will take more time for you because you need to understand the requirements, right? That will take more time to write the test cases. That's a complex task. Okay. So chances of having unidentified paths during this testing. So manual testing, you might miss some flows because you don't have a time to focus all the cases. So that is the reason. So black box testing or functional testing or manual testing also we call this, right? So this black box testing is so a bit to know all manually how to perform. That's why there are some disadvantages also. So what are the different test data you will prepare? So valid test data, invalid test data, boundary test data, wrong data, absent data. So these are the different types of test data. So valid data means it is necessary to verify whether the system accepts a valid data or not. So that you have to give. For example, your username, password. You have to give correct username, password to log into your account. That's a valid data. Invalid test data means, so you're giving invalid values. So then the system will give a proper error message. So that means that is notifying that you are given invalid data. That's invalid test data means. And boundary test data. Boundary means at the boundaries. So we're going to discuss now. At the boundaries you have to give. So for example, one field accepts 50 characters. So boundaries means 0 and 50 or 1 and 50. 1 is the lowest boundary, 50 is the maximum boundary, right? That boundaries also you have to check. Okay. Now, black box testing techniques. What are the different black box testing techniques? So we have equivalence class partitioning, boundary value analysis, and we have a decision table testing, and we have state transition testing, and last one, error guessing. These are the 5 black box testing techniques are available. So what are the 5 black box testing techniques? Equivalence class partitioning, ECP we call that. Equivalence class partition. Second one, boundary value analysis testing. And third one, decision table testing. Fourth one, state transition testing. Fifth one, error guessing. So error guessing, these are the 5 black box testing techniques. Let's understand one by one. So
Mhm.
what is equivalence class partitioning? Equivalence class partitioning. So that means, so if there is a input range, okay, you divide that input range into equal parts and then label them valid and invalid. So that's how this technique is used to generate more valid and invalid test cases. So you generate the test case for each valid, one test case, for invalid, few more test cases. So mainly these techniques are used for writing the effective test cases. More test case generation purpose, these black box testing techniques are widely used. Suppose, so an input box or edit box, right? A text box. So that accepts 50 characters. How you will equally divide this 50 input range? So one is the equivalent classes means this one. See 1 to 10, one equal classes. Equal means the range should be same in all the classes. This is the one class. 1 to 10 is one class. 11 to 20 is another class. 21 to 30 another class. 31 to 40 another class. 41 to 50 another class. Then 51 to 60 another class. These many classes you are going to divide. Each class between what is the range?
10.
10. So that's how you categorized. You divided the equally classes. So this is the equal. So instead of testing 1 to 10, you take one of them here. Right? For example, 5. You take 5. If 5 characters, it works. In all other characters, it works. Then you can make it to pass this class. Then come back to next this class. You take one, like 17 or 19 characters you take and give input to this input box. If it works 19 characters or 18 characters, then you don't need to test other numbers. That means you are saving the time, right?
You're not testing 1 to 10 or 11 to 20. You're just testing somewhere in between the data range, so you know it's working.
Exactly. So even you can test these boundary numbers also. These boundary numbers also. If it works in all other numbers, you don't need to test. Obviously, other numbers it works. That's the how they going to develop the boundary conditions and this class partitioning. You can test that, and then same way here also. Here also. More input data, test data you want, you can so partition like this, equal partitions. See now 51 to 60 is invalid case, right? So this accepts only 50, but here again one more you can write here 51 to 60. If you write a 51 to 60, so this is not going to be done. So if you write 51 to 60, so this is another class. So so this class 1 you take, 1 you take, 1 you take. How many? 1, 2, 3, 4, 5, 6. 6 input fields only you can test instead of testing 50 times. So that means you are saving the time also, right? And efficiently you are testing. So this is most effective ways of testing an input boxes. Instead of testing 50 times, you equally partition this into equal classes. Then each class you take one input. So for example, 6 characters. Okay. So just give 6 characters there. If it accepts 6 characters, then all other characters in this class it will pass. Then you can make it a pass. Next, the same here also. You take the same. For example, 12 characters. Okay, 12. 12 characters you give that. So if it accepts 12 characters, you make it pass. Same way here also. So like this here also. Here also. and here. So it should not accept here, right? So it accepts 50 only. But if you give 51 or anything above 50, it should not accept. So that's how you'll test. Otherwise, I don't want these many 6 test data also. I want to do very less. How can you divide equally this 50 one more way? Equal partitions. How can you divide 50 into equal classes?
So you want to divide by 10?
Hmm?
Divided by 10?
You did already here. So another less, I don't want this many granular small partitions. I want only less. These are 6 inputs right here.
You want less than 6 inputs?
So you are giving 6 inputs here, but I don't want these 6 inputs. I want to reduce again because I have less time.
Divide it again.
How can you divide this 50 into equal classes? One more way.
Oh, equal classes.
What is the other way? Equally you can divide 50. Ayyo. How can you divide equally this 50?
Sorry, my brain just froze for a second. Can you help me out here?
Yeah, 1 to 25, right?
Oh yeah, just half it.
And 26 to
50, yeah.
50. You can see equal classes means here 25, here also 25. And also 51 to 75. Just
So
3
now we have
classes.
3 cases.
Equally means you have to think. So that each class should have same number. Here also same number, here also same number. So this is the negative case. And these two are valid cases. So this is the, you don't need to test all here. So that you can take one of them. If, for example, 20 characters you take, if it accepts, you don't need to test other places. In 26 to 50 also you take some 40 characters or 35 characters. You don't need to test other characters. So this is the dividing the input range into equal classes. So is this equal classes or not?
Yep.
That's the equal, any input range, not only this one. I'm just giving an example here. If they ask you equally divide an input range means you can apply this equivalence class partitioning. ECP we call it. See, here itself it is telling equal class partition. See this partitioning, right? We are partitioning. That's a equivalence class partitioning means. Okay, so let's move on to the next one. Any doubts here before moving on to the boundary value analysis?
No, this one's fine.
So you need to understand this, very important, all these techniques. So in the interviews, they will ask all these questions. So you have to explain what is equivalence class partitioning. So what are the black box testing techniques, all of them. Okay. Now, so what is boundary value analysis? See, boundary value analysis. So testing the application input box field at the boundary values. At the boundary means inside the boundary, yet exact at the boundary and outside the boundary. So these are the boundary values. So exact boundary places, inside the boundary, outside the boundary. So that is called boundary value analysis. So there are 6 test cases you can generate. One is minimum value, minimum plus 1 value, minimum minus 1, maximum value, maximum plus 1, maximum minus 1 value. So these are the 6 values you can get with this formula, any input range if they are giving. Okay. So example, for example, here is see that password should accept 6 to 12 characters. Now tell me what is the minimum and what is the maximum here?
Well, minimum is 6, maximum is 12.
So 6 is the minimum and 12 is the maximum. Now apply
Mhm.
this formula for this, Say
So
minimum
if we're
means
taking the minimum value, it would be
6.
6, and then minimum plus 1, which would be 7, and then minimum minus 1, which would be 5.
5.
And then for 12 at the maximum, you would do plus 1 equals 13. If you do minus 1 on 12, 11.
So now you draw this. So the same, the boundary conditions, you draw this. So they are accepting 6 to
12.
12, right?
Mhm.
So this is the range you have to give for this password edit box.
Mhm.
So the password edit box, you know, any either 6 you can give, 12 you can give, or in between that, any characters you can give. That should
Mhm.
accept. So this one is inside, right? This is the
Mhm.
inside. So this is inside, right?
Mhm.
But outside means this one, right?
Mhm.
Outside means this one, right? 12
Yep.
out. So this is the out.
Anything like basically anything outside the acceptable range.
Right. So this is the inside.
Mhm.
So now see the 5 means this is the 5. 5 and anything 6 below, that's
Mhm.
outside of the range. And 6, 7, 8, 9, 10, 11, right? So
Mhm.
all these values are inside values. So now see here, now tell me, and this is the 13, right?
Mhm.
So these are the boundaries, exact boundary conditions, right? This is the boundary. So
Mhm.
minimum boundaries. So the maximum boundaries.
Mhm.
So this is exactly at the boundaries, at lower boundary, right?
Mhm.
So lower boundary. So this is the maximum boundary, right?
Mhm.
Exact max boundary. Right? So maximum boundary. So now if you see in this, what are the invalid inputs? What is the valid inputs? Can you tell me?
Anything between 6 to 12 is valid. Anything outside of
Valid.
it, so 5, so 6 minus 1, or 12 plus 1
One
are
are
invalid.
the invalid. Exactly, right? So
Mhm.
anything, the minimum boundary outside, maximum boundary outside, any values are invalid values. That means the password should not accept anything maximum boundary outside, minimum boundary outside. So exact minimum are inside are valid values. So that is how you can develop the test cases. You can write the test cases for this. So this is how boundary conditions you got testing. Testing at the, you need to test with the 6 and 12. And take one middle one, okay, any one of them. So not required all. So you take one middle, and then outside boundaries, you try with the 5, you try with the 13, you should not accept. The password should not accept. Password should throw an error message. So this is the boundary value condition, testing the input field at the boundary conditions is called boundary value analysis. Okay, are you clear?
Yep.
Okay. So let's go and we'll see what are all the test cases we can develop for this. See how many test cases we are going to generate. Let me show you that. All that, this is how you will write the test cases. Okay. Let me show you that. See, without any characters, so that means empty. So that's what I have given here on the top, right? Absent data. Absent data means empty data. Absent data means empty data. So test password with so encrypted format only or not. So enter special characters. So they will give a rules. This is the requirements they have given. So
Mhm.
this is how the customer will give you the requirements. Password field should accept 6 to 12 characters only. First requirement. Okay. Second requirement. Password should contain at least one uppercase letter. This is all and, okay, and cases.
Mhm.
Password should contain at least one number. Password should contain at least one special character. That means password should contain uppercase letter, one number, one special character. In between these 6 to 12 characters only. Then only that is a valid.
Mhm.
Anything other than that, it's not a valid. So based on that, you need to generate the test cases. How can you generate? See that. So this is how to write the test case. Test case name. This is the test case name. How to write it? Verify entering invalid password less than 6 characters. See, I put a generic word.
Mhm.
Less than 6 means anything, right? It's a 6 or 2, 3, 4, anything. You got it?
Yep.
That's a one test case. So verify entering invalid password more than 12 characters. Another test case I generated. See that. So for this 13, I generated another test case. For less than 6 anything, I generated another test case. Next. Verify leaving the password field blank. See, in complete blank. Wrong, no, absent data, one test case I generated. What is that? Leaving the field blank, one test case. Next, verify entering the valid data in the password field. Valid data means 6 characters, 12 characters, in between 6 and 12. See, it all comes under this test case. I'm not specifically writing, okay, enter 6 characters, enter 12 case. I'm not saying. One generic test case I have written. This is the test case how to write. Next. So verify entering only numbers in the password field. Is this a valid or invalid?
This would be invalid because you need
Exactly.
yeah, you need a mix of both the alphabets and numbers.
Exactly, right? And
special characters. Yeah.
So that is not there in this test. That means it is testing. This is also one test case. Maybe people can enter, right? Only numbers they can enter, right? There is a possibility. So you have to think all these possibilities. We don't know which person will enter, but you have to test it.
Sorry, this is an example of what, a negative test case?
Yes, exactly. So these are also negative test cases, and this is also negative test case. So verify entering only alphabets. So verify entering only special characters. Verify entering alphanumerics only. Alphanumerics means you write alphabets and numbers. Verify entering alphabets and special characters. That means missing here numbers. That means this is not a valid, right? Again. Verify entering numbers and special characters. That means alphabets are missing here. Verify entering without uppercase letter in the password. See that this many cases we need to generate. We don't know, right? How people will enter, what they will enter, but they have to fulfill this. This is the customer given for us. So you are testing these many ways. So this is the how you will derive the test cases based on these requirements. See, this is the only 3 statements, 4 statements they have given. But how many we generated test cases here? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 test cases. Only for password field. So like this, you need to generate the test cases. Okay? This is very important. I'll give one more task. Write the test cases and send to me. Okay? Tomorrow. This is the task you need to do. Write the test case for below. Same, okay? Same as above, but extra few more I'm adding here. Password must contain 6 to 12 characters, okay? Must contain both upper and lower case letters. Must contain numeric, must contain a special character. Should not contain username or first name or last name. That means 3 extra conditions you got it here. That means your password should not contain your username, your first name, your last name. Okay? So that is the write this test cases for this and send it.
Sure.
Okay? So you have to write this test case extra. Already till this I have given. But think
Yeah,
this,
just for the
this
last
point,
three conditions. Yeah.
last three conditions you add extra. But for
Mhm.
this also you write, okay?
Mhm.
If you write only, this is the only area you need to focus.
Mhm.
This is a very, very important. Writing the test case is the crucial for the tester.
Mhm.
If you practice now only, you will, whenever you enter into the company, it is going to be easy for you.
Mhm.
Okay?
Mhm.
Yeah. So you have two tasks. One is that difference between waterfall and agile methodology,
Mhm.
and writing the test cases for this one. Okay.